I guess the first thing I want to talk about is winter is just around the corner. It's the time of year when your electrical system has to be at peak performance for this electrical system work. So today I really want to kind of talk in two parts. I want to talk about why it's so tough in the wintertime to start vehicles and make electrical systems work. Then the last part, I'm going to give you some tips on what you can do to make sure your vehicles are ready for winter. So, in the fall right now, I'm sitting here in Arkansas and I have a sweater on today, but it's going to be 72 degrees. Typically in the fall, you just got out of the summer where you got all the hot weather that's very damaging the batteries. But when we get to the fall, temperatures are pretty mild typically. So you talk about it easy for the electrical system is the amperage it takes to crank the engine's low, your battery requirements are low. So really your electrical system is pretty well taking it easy because it doesn't have to work real hard in the fall months. And it can lull you to sleep a little bit, and let me explain why. As soon as the first day gets cold, you always have the vehicles, several vehicles doesn't start. And everybody says, why all of a sudden the first cold day? Is because your cranking amps can more than double the first time it gets cold. As this current goes up, it's going to put tremendously more stress on your starter. The increased amount of current that goes through from your batteries is very stressful on your batteries. And then, even though your resistance remains the same, as your current requirements go up to power that starter to start the vehicles, even the same amount of resistance, when you double the current, you can easily double the amount of current and double the voltage drop in those cables. So all those things, the first day gets colder, when it gets cold, all those things are going to impact the ability to be able to start and make your electrical system work as it should. So if you look at this chart, it says that at 80 degrees, your battery is 100% efficiency and so is your engine 100. But as you see, as you go down a temp, you get to 0 degrees, your battery is 65% as efficient as what it was at 80, and yet your engine is 250 times starter. So it's a roadmap for disaster in the fact that the colder it gets, the harder it is to start the engine and the less efficient your batteries are. So let's look at all aspects of this electrical system. Let's first of all look how the batteries are impacted. You can see on this diagram I'm showing 4 batteries. If you're a school bus, you have 3, or you're a municipality, you have a smaller vehicle, 1 or 2. It still is applicable how this works. So if I look at summer on a heavy-duty vehicle, is the starter will draw somewhere on a large block engine about 650 amps on average it takes from the battery. So if you divide 600 in this example by 4, each one of those batteries would be supplying 162 amps. Now, if you folks have ever load tested batteries, you usually half the CCA to load test a battery, you can see it's substantially more than that. So it says in these warm weather type of conditions, the batteries aren't working real hard to be able to crank the engine. But let's look at the same vehicle. If all of a sudden it's 0 degrees, that same starter motor, that same engine could pull in excess of 1,700 amps. I'm not talking about inrush current. I'm talking about once the engine starts to roll over, it could be pulling 1,700 amps. If you looked at that example, you divide 4 batteries by 1,700 amps again, each battery is we're supplying 425 amps. That's a substantial difference in the first example of 162. So you're basically almost 59% more energy out of those batteries. So you can see as the colder it gets, it does put a lot of stress on the batteries during cranking. So how is the starter impacted? Well, first of all, because the oil temp and the oil viscosity and all the other factors, as I said earlier, is those current draws could more than double. Current and amperage and heat are directly proportional. So the more current you flow through that system, the more it tends to want to heat up, and that causes insulation to be degraded. So it's just very, very tough. Puts a lot of stress on all the components of that starter when it's cranking and pulling that much current in wintertime. So next thing let's talk about is the impact of having voltage drops in those cables. And I'm going to give you an example, but just remember this. The more voltage drop you have in those cables means you have less voltage at the starter. And if you have less voltage at the starter, you have reduced cranking speed. Voltage and speed, cranking speed, are directly proportional. So the lower the voltage is, the lower the cranking speed is. So let's give you some examples how that works. Using Ohm's law, if I say that I have, I'm going to use an example. We're saying you should typically on a heavy-duty vehicle have 0.001 ohms of resistance in the cranking cable. That's total resistance. So using a warm weather example, if I was pulling 650 amps from the starter, so 650 amps goes from the batteries to the starter, that 650 amps has to return back to the same battery pack. You can see on the voltmeter, my voltage dropped to 11 volts at the batteries during cranking, and if you look, I've got 10.35 at the starter. So that means I have a 0.65 volt drop in those cranking cables. So you can see why you say, why do I have 11? Well, even when the current will drop at the batteries as they're supplying energy to crank. So you can see that the 0.65 is not excessive amount of voltage drop. Now remember though, before I go into the winter example, I said the resistance of this circuit was 0.001. Now, unless cables get fractured, broken, strands get broken, corrosion, whatever, in a perfect world, the resistance would never change. So let's look at what happens in that cold weather. I still have the 0.001 ohms of resistance. I still have the 1700 amps of current flowing. So if you look at that, now I have a 1.7 volt drop. I can't see these numbers. And I'm having real trouble seeing these numbers. So excuse me 1 minute. It's what happens when you get old, folks. You can't see nearly as well as what you did. In this example, I got 9.35. That's what the voltage would drop at the batteries because of the additional current draw. And you can see because I have the 1.7 volt drop in the circuit, I would only have 7.65 at the starter. You remember on the warm weather, I had 10 something, now I'm down to 7.65. So that starter has no brain. It doesn't know it's cold. All it sees is reduced voltage, which says that will have an impact on how much speed that motor can generate. Now, something that rarely gets thought about is the charging system is critically important in cold weather. Now, the reason the starter is the alternator system is so important in cold weather is batteries don't want to take a charge in cold weather. And at 14 volts, some batteries, flooded batteries, be lucky to take a couple amps an hour because the electrolyte becomes like jelly and it becomes very hard for that battery to want to accept a charge. So let's look at this is a charge curve that shows what voltage battery people would like to see on their batteries as a temperature. So you can see at 80 degrees, 14 volts is somewhere in that area, but when you see you're down to 0 degrees, if you really want to optimize the charge rate on a battery, is that alternator's voltage needs to be up over 15 volts. And if you look at what happens in our marketplace or our alternators, they're flat regulated at about 14.2. So they're going to run 14.2 in wintertime. They're going to run 14.2 in summertime because typically whether it's a school bus or heavy-duty truck is the battery pack is mounted external from the engine compartment, so they get no temperature rise or whatever. So the alternator only looks at what the input temp is, so it never changes, so we just regulate it. But you can see by looking at these charts, we're substantially less than probably optimal charging voltage in cold weather. I think a lot of times where people get fooled is you'll start the vehicle, the alternator shows it's charging, the lights are bright, but guess what, folks? You're not putting a whole lot of current back in the battery. So everything looks good, but it takes a long time to put charge back in those batteries. So I've kind of highlighted all the areas now that winter really impacts the fact that batteries don't want to take a charge. Your charging system better be perfect. The starter's going to draw a lot more current. The batteries have to supply a lot of more current. Plus, they don't take very much current once the vehicle is running. So how do you get ready for winter for these electrical system issues? And it's pretty well a 1, 2, 3 process, folks. We have, 1984, we made the first RP129 that showed fleet technicians how to do this test. Since we implemented this new RP in 1984, it's been changed 3 times. It's just now going through a revision process, but let me kind of explain how this 1, 2, 3 approach works and how you can do this to make sure your vehicles are ready to go. 1, I'm talking about cranking now on this one. 1, 2, 3 for cranking, then there'll be a 1, 2, 3 for charging. First of all, before you go in the winter, take all the batteries apart and test with a quality tester. When I say take all the batteries apart, you can't just take the positive cables off or the negative cable. Yes, you can test like that, but what you really want to do is take all the cables off so you can individually test each battery with a quality tester. The other real important thing is you want to clean the terminals before you make the test. And then when you put it back together, after all the batteries pass, if they pass, put them back together. If they don't pass, replace them. You want to make sure you clean those cables because those cables have to transfer that energy. So if you clean the lead pad areas of the battery and you don't clean the cables that go to them, that still could cause you problems. You want to have good metal-to-metal contact after all the batteries have been tested. So the next step is you want to conduct a voltage drop test on main cables. Remember when I showed you the examples of how much voltage drop you could have? The TMC test says use a 500 amp load, or your new electronic testers will do it for you automatically. But you apply a load through the circuit, and then if you're using a carbon pile pole 500 amps, you're allowed a 0.5 volt drop. If you're using one of the electronic testers, it will come back and tell you if you passed or failed, and it'll tell you which side of the circuit is good or bad. So if you use this test, and the reason we don't use a starter motor is, how do I know your starter motor is any good? If you use a known good test using Ohm's law, I can tell you the voltage drop, tell you what kind of current you have, and I can actually calculate the resistance, and that's what we're doing. We're trying to make this repeatable every single time. Third thing to do in a cranking circuit is do a voltage drop test on your control circuit. Most of the new starter motors now have a slave solenoid on them. And all you have to do is a very simple test is make sure you have the proper voltage when you turn the key switch on. That's as simple as that. So, but it's 1, 2, 3. It's test the batteries, test the cables, test the control circuit. There is no test on starter motors in the marketplace today. All we're basically saying is, if you do these 3 tests and they all pass and the vehicle starts, you should be ready to go. That's kind of it on what you can do on a cranking motor. Now let's talk about the charging system. It, again, is 1, 2, 3 steps. If you already checked the batteries, you don't have to do it again. But if you're just checking the charging system by itself, the first thing you want to do is, again, take all the batteries apart, clean the terminals, use lead adapters when you test all the batteries to make sure each battery passes the test. If they don't pass the test, replace the batteries. The other thing I should mention before you do this test I'd always use a minimum of 12.4 volts. If you don't have at least 12.4 volts, what would I do? I would charge the batteries before I conduct the test. You wouldn't drink a Pepsi and tell if a Pepsi is good if it was half gone before you started. So you want to make sure it's a full bottle before you start. Next thing you want to do is you want to do a voltage drop test on the charging cables. And that's the same thing as a cranking, except remember, current flows from the alternator. Typically, on most vehicles, it will flow from the alternator to the starter as a junction point, pick up the big cables, go back to the batteries. Whatever goes out to the battery has to come back. So if voltage is critically important in cold weather, and you got a voltage drop in your charging circuit, that's going to impede the ability to charge batteries. And honestly, a couple tenths of a volt in cold weather will make a tremendous difference of the rechargeability of those batteries. So it's critically important that those charging cables are good and can supply the right voltage to the battery. Next thing to do is test the alternator. When you test the alternator, there's kind of two parts in doing a test of the alternator. With no loads on, you run the RPMs up. All you're looking for is the consistency of the regulator. It should not go up with frequency. In other words, the faster the rotor speed, you want it to stay. If it starts at 14, you want it to be at 14. You run the RPMs up. The last part of the test is you want to test the alternator and make sure it has the proper output. Use a carbon pile load tester and clip-on amp meter. You can load down the battery at around 12 volts, and the alternator at full rated speed should put out about within plus or minus 10% of the rated output of the alternator. If you have an electronic tester, it doesn't actually measure current, but it looks at what we call high ripple. And if you have high ripple light will come on indicating you either got a problem with the diode trio, a diode in a bridge, or the stator. Both are good tests. Both will tell you if the alternator is working or not. So those are the 1, 2, 3 steps of cranking, the 1, 2, 3 steps of the alternator. RP 129 is available. We will post that, but again, it shows you explicitly how to hook your meters up, how to make the test, and why they're important. So if you follow these simple instructions, your vehicle should be ready for winter. And lastly, you, the technician, will probably need coat, gloves, and a hat because it will be cold this winter.